Hello viewers, in today's class we are going to discuss some problems related to linear differential equations, right? So here we have some problems related to linear differential equation which will be solved by method of integrating factors, right? So here let us first take this problem that is dy over dx plus 4y is equal to e raised to minus 3x, right? So we'll solve this linear differential equation by method of integrating factors, right? So let us quickly see what is a linear differential equation and what is meant by integrating factor, right? Now see, a linear differential equation of first order and first degree is defined like dy over dx plus py is equal to q, right? So any equation of this form is known as linear differential equation of first order and first degree, where p and q are functions of x, right? Okay, or in other words, p and q may be some constants, right? Okay, now to solve these type of linear differential equation, what we do, we find the integrating factor. So the integrating factor if is equal to e raised to integral p dx, and the solution of this differential equation is given by y times integrating factor, then we have integral q times integrating factor dx plus c, right, where c is the constant of integration. So these type of linear differential equations shall be solved by using this result, right? So let us compare this equation with this one, right? So now if we see the value of p is 4, right? The value of p is 4 and the value of q is e raised to minus 3x, right? And here we see that p is a constant and q is a function of x, right? So the first step is to find the integrating factor. So the integrating factor of this linear differential equation is e raised to integral p dx, and p is 4, so here we have 4 dx, right? So now we can write e raised to 4 and integral dx. Now integral dx is simply x, so we have e raised to 4x, right? So the integrating factor of this differential equation is e raised to 4x, right? Now the solution of this differential equation is given by y times integrating factor. The integrating factor is e raised to 4x, and then we have integral, and the value of q is e raised to minus 3x, and the integrating factor is e raised to 4x dx plus c, right, where c is the constant of integration. Now we can simplify this expression. So we have y e raised to 4x, and here we have integral e raised to minus 3x plus 4x is simply x, right? And here we have dx plus c, right? So now we can write y e raised to 4x. The integral of e raised to x is simply e raised to x, and here we have plus c, right? And dividing this term by e raised to 4x, we have y e raised to x plus c over e raised to 4x, right? So now we can separate the terms. So we have e raised to x over e raised to 4x plus c over e raised to 4x. And now we can write y is equal to, taking this term to the numerator, we have e raised to minus 3x plus c e raised to minus 4x, right? So taking this term e raised to 4x to the numerator. So this is the solution of this differential equation, right? And remember, here c is the constant of integration, and the solution is expressed like y is equal to f of x, right? And f of x is e raised to minus 3x plus c times e raised to minus 4x, right? Now let us take the second problem. Now let us take this problem, that is y prime plus y is equal to cos e raised to x, right? So y prime is equal to dy over dx. So we have dy over dx plus y is equal to cos e raised to x, right? Now this equation is again of this form, right? So if we compare this equation with this one, then here we can take 1, that is dy over dx plus 1y is equal to cos e raised to x. So the value of p is 1 and q is cos e raised to x, right? So let us find the integrating factor. So integrating factor, which is abbreviated as IF, is e raised to integral p dx. So p is 1, so here we have dx. So this is simply integral dx. So this is e raised to x, right? So now the solution of this differential equation is given by this expression. So we have y times integrating factor. So integrating factor is e raised to x, and here we have integral q is cos e raised to x, and the integrating factor is e raised to x, and here we have dx plus c, right? So this is y e raised to x, and this integral can be written as e raised to x cos e raised to x dx plus c, right? Now we have to evaluate this integral, right? And this integral can be easily evaluated by method of substitution, right? So what we can do here, we can take e raised to x is equal to, say, u. So du over dx is e raised to x. So du is e raised to x dx, right? So for e raised to x dx, we can write du. So we have y e raised to x. Here we have cos u, and for e raised to x we have u, and e raised to x dx is du, right? And plus c. So now we can write y e raised to x, and the integral of cosine u is sine u, right? And c is the constant of integration, right? So now we can replace u by e raised to x. So we have y e raised to x and sine e raised to x plus c, and we can now take e raised to x to the denominator. So we can now write e raised to minus x sine e raised to x plus c times e raised to minus x, right? So this is the required general solution of this differential equation, which is again of this form: y is equal to f of x, right? And c is the constant of integration. So this is the general solution of this differential equation. Now let us take the third problem, right? So here we have 2 times dy over dx plus 4y is equal to 1. So here what we will do to reduce this differential equation to this form, we'll divide both sides by 2, right? So we have dy over dx plus dividing both sides by 2. So here we have simply 2, and here we have half, right? So now the coefficient of dy over dx is 1 here, because here also we have the coefficient dy over dx as 1, right? So now comparing this equation with this one, p is 2 and q is half, right? And here it is very interesting to note that P and Q are both constants. So now the integrating factor is given by e raised to integral p dx, right? So here we have integral e raised to p dx, integral p dx, p is 2, so we have 2 dx. So this is e raised to 2 times integral dx, so this is 2x, right? So the integral dx is equal to x, right? Now the solution of this differential equation is given by this expression. So now we have y times integrating factor, which is e raised to 2x, and here we have integral q. Q is half, and integrating factor is e raised to 2x. Here we have dx plus c, right? So this is y e raised to 2x, taking half outside. The integral, we have e raised to 2x dx plus c, right? Now we have a very simple integral here. We know that integral e raised to mx dx is equal to e raised to mx over m, right? So here we can now write half integral of e raised to 2x, e raised to 2x over 2, m is 2 here, and here we have c, right? So this is e raised to 2x over 4 plus c, right? So now we have y e raised to 2x is equal to e raised to 2x over 4 plus c, and dividing both sides by e raised to 2x, we have y here, e raised to 2x get cancelled, so we are left with 1 over 4 plus c divided by e raised to 2x, right? So now we can write y, and here we have 1 over 4 plus c times e raised to minus 2x. So taking e raised to 2x to the numerator, right? So this is the general solution of this differential equation.